t, we would have random number equals 1 minus e to the minus lambda t. And obviously, we can take the e over that side and 1 minus 0.539 on the other side, and we would get e to the minus lambda t equals 0.461. So, in other words, if we know lambda, the mean rate of arrivals, we can work out t, what the average, what the inter-arrival time will be for that particular random number. And then we can have another random number and another inter-arrival time. And we can simulate these people walking into the shop randomly. So that is how we're going to do it. Of course, what we've got to do is get from here to getting the value of t. So that's the next stage of the process. Now, obviously, we're assuming that we have a value of lambda. We know the lambda value. I'm going to assume, for this queuing situation, that lambda is 1 per minute. So in other words, putting lambda is 1 in here, you get e to the minus 1 times t, or e to the minus 2 is 0.461.
Do you know when you moved it across, so why wasn't the lambda t a positive?
No, sorry, e to the minus lambda t is positive. That is something raised to the power. It's like 10 squared or 100, isn't it?
Okay.
It's e to the power minus lambda t. So when you take it over, it's that becomes the positive, right? But that just stays as it is. Okay. So e to the minus lambda t is 0.461. If lambda was 1, e to the minus t is 0.461. Now we're left with, how do we get from there, how do we get from that to what is the value of t? And there are 4 ways of doing it. One is, we could use tables of e to the minus x, if we have them available. And obviously if you needed them in the exam, they would be available. But you could use tables of e to the minus x to do that. You could use logarithms to do that, and I'll explain that in a minute. You could use a calculator to do it. It's not quite as easy as it sounds. Well, it's easy, but I mean, it's not straightforward as it sounds. Or, obviously, you could have used the graph and just taken the inter-arrival time. You could plot out the function and use the graph. I'm going to put that in brackets because that's going to be the least accurate of the methods. But as I say, if we use the graph, obviously we're relying on how accurately we've drawn it. If we do these other methods, we're getting precise calculations. Now, we've got e to the minus lambda t is 0.461. So, if we had tables, let's suppose we look at the first alternative. If we had lambda is 0.461, then what we're left with is trying to find in here where the answer is 0.461 and somewhere up 0.45, 0.46. So it's somewhere between 0.67 and 0.68 for our value of inter-arrival time. Am I reading that right? Sorry, it's 0.7, between 0.77 and 0.78, 0.46, yes, it's 0.7. So it's between 0.77 and 0.78 would be a value of 0.461 when you looked it up on the tables. So that would be our travel time. Remember, lambda was 1 per minute, so that will be the travel time in minutes. 0.77 of a minute is about 46 seconds. Okay. So that's one way, but of course you've got to use the tables. You're not looking at the value of x, you're looking at the tables to get you the value of x, is the way to do it. So in other words, you've got the answer, you've got to work back to to what the value was been. Now, the other way of doing it which is probably slightly easier, but I mean it depends on your own point of view, I suppose, is to use logarithms. And if we use logarithms, then basically we take, you don't worry too much about this, but we would take logs of both sides to the base e. Now log to the base e of e to the minus t is minus t, okay, you have to accept that that is the case. Log to the base e of 0.461, on all your calculators you have log to the base e on the scientific calculators, on the university calculators. You just look up, just put in 0.461 and press log to the base e, and you will get minus 0.774 from the calculator. So t, obviously they're both minus, swap them around, t is 0.774 minutes. So that's another way of doing it for 46.44 seconds if you want to do seconds. So, you know, you can look it up on tables of e to the minus x. You could take logarithms and then just look up the log off the calculator or again off tables if you've got log to base e tables. I mean, all this is really saying is, you know, log to the base 10 of 10 squared is 2. You know, if you it's just log to the base e of e to the minus t is minus 10. It's the same process, but logs to the base e. So that's another way of doing it. If you use the other method was use a calculator. Yeah, if you use a calculator of e to the minus x, it's the same problem that you have. So this is not quite so easy. What you'd have to do is you'd have to put a value of x in and see what the answer came out at. And if it didn't match your random number, you'd have to put another value of x in and see what it came, and home in on the value. You know, so it's a trial and error situation. You've got to work backwards to get to make sure it works. So it's a bit more fiddly that way, doing it on a calculator, but you still could do it that way if you wanted to. So in other words, just use a calculator for tables of e to the minus x rather than the log tables. Or you could use the graph as I said. So whatever way round, we could simulate an inter-arrival time.